Hi dear students, so let's continue the topic from chemical kinetics. So here you have the new topic that we are going to discuss here is rate law, order and molecularity of the reaction. So first we will try to understand what is rate law. Okay, so I have given the definition here. Let me say the rate law, we can say it is an expression basically. So how this expression is found out? This expression is found out experimentally. That is very important. So if you see here, the experimental expression of the rate of a reaction, the experimental expression of the rate of a reaction in terms of what? In terms of concentration of the reactants alone, of the reactants is known as what actually? Rate law. Understood? So very simple. If you have a reaction, for example A plus B giving you product. Okay. Now I can write the rate law as rate is proportional to concentration of A. Concentration of A, how you write? You will put it in square bracket, right? So concentration of A raised to some value X and product, so multiplied by concentration of B. Correct? So put it in square bracket, then some term Y. Here the important thing here is X and Y, they are experimentally determined values. It is not the stoichiometric value A and B. That is what is very important here. Okay, so here please understand, rate law is an expression that is determined experimentally. Okay, so rate law is what actually? The experimental expression of the rate of a reaction expressed in terms of what? Concentration of the reactants is known as the rate law. Now here you can see here the rate of the reaction is proportional to what? The product of what? Molar concentration of the reactants. Molar concentration means what? Number of moles per liter, or it is molarity. Correct? Molar concentration of the reactants with each term. So here A and B, with each term raised to a power, here X and Y, raised to a power or exponent that has to be found what? Experimentally. That is very important. Here X and Y may be equal to A and B or may not be equal to A and B. That's why I am saying X and Y, they are determined experimentally. Okay, so when you remove the proportionality sign, rate is equal to some constant into A power X and B power Y. This constant K is called rate constant. What is that? Rate constant. And please understand that here the rate constant will become equal to rate of the reaction when the concentration of A and B becomes equal to 1, or concentration of A is 1 mole per liter and concentration of B is 1 mole per liter. Understood? So K is called rate constant. Clear? So next we will try to see what is the difference between we will come to the order actually. So here order also we can easily say here the total order of the reaction. So if you know the rate law, for example, this is the rate expression. If you know the rate law, from that you can easily determine the order. Order will be equal to X plus Y. So here A have the coefficient X and B has the raised to the term Y. So X plus Y will give the total order of the reaction. And please understand, in some exams they will ask what is the order with respect to A. In that case the order with respect to A is X and the order with respect to B is Y, and the overall order of the reaction is what? X plus Y, and we will represent that by the letter N. N is equal to X plus Y will give the overall order of the reaction. We will come to that in detail. Okay. Hi dear students. So next we will go in detail what is rate constant. We have seen that in the rate law expression. So there is another name for rate constant, that is called specific reaction rate. Sometimes in the question paper they will give you, they only talk specific reaction rate. Okay, so whatever be it, rate constant or specific reaction rate, it indicates the rate constant K actually. Okay, now consider the chemical reaction N1A plus N2B giving M1C plus M2D. Consider this as a balanced chemical reaction. Okay. Now we know that N1, N2, M1 and M2 are the coefficients of A, B, C and D respectively. Correct? So just now I am telling on history. So here earlier, as per the law of mass action, you might have learned this in chemical equilibrium. So as per the law of mass action proposed by Goldberg and Wake, the rate of the reaction is equal to rate constant K into concentration of A, concentration of B raised to the power N1 and N2 Please understand, here they are taking the stoichiometric coefficient N1 and N2. This was the initial way in which rate was determined. But there come a lot of opposition, or there come a lot of scientific reasons. They start to tell that this N1 and N2 can be a varying quantity. What does that mean? Listen, I am taking an example, H2 plus O2 giving H2O. Now I know that while balancing there are two oxygens, so I kept 2 here, so here 2. So this is a balanced chemical equation, correct? So as per this equation, we know that here N1, I am taking N1 as H2. So N1 A is H2. So N1 is what? 2. So here B is O2. So here coefficient N2 is 1 actually. So this is the balanced chemical equation. Now when I write the rate law as per the law of mass action, N1 will become 2 and N2 will become what? 1. Now suppose another person now balances this chemical reaction in another way. For example, he divided by 2. So this becomes half. Okay. So this becomes 1. Now if you see, this is also balanced. If you see 2 hydrogen, half oxygen. So half oxygen means 1 oxygen. So that means 1 O. This is also balanced, but here the N1 will become 1 and N2 will become half. So this is a problem. Every time you can balance a chemical reaction in n number of ways. So what happens? The N1 and N2 changes and the rate changes. So the scientists, they propose that this N1 and N2 should not be coefficient. So the law of mass action cannot be used for determining the rate of a chemical reaction. Then they come up with the concept called the rate law. Just now we have learned. That is an experimental expression calculated experimentally. You don't want to learn how it is experimentally calculated. It is not there in the syllabus. So whenever in the question they say it is a rate law expression, then the whatever term that is raised to the concentration of A, here X, that X denotes the order. Please understand, order of a reaction is always calculated or always taken with respect to what? Rate law. It is not based on law of mass action. So rate is equal to K into A power X B power Y, where X and Y are quantities that are determined experimentally. X denotes the order with respect to A and Y denotes the order with respect to Y. Okay, so here X denotes the order with respect to A and Y denotes the order with respect to B. Now the overall order of the reaction will be what? Actually X plus Y. Understood? Now sometimes students may ask, sir, whether this X and Y can be equal to N1 and N2. It can be, because it is an experimentally determined quantity. Sometimes it may equal to, X can be equal to N1, Y can be equal to N2, or it may not be equal to. It can be equal to or not equal to. Understand? Now what and all factors the rate constant depends? Rate constant does not depend upon the concentration of the reactant. Rate, please remember, this is the most repeated question from this chapter. Rate constant never depends upon what? The concentration of the reactant. It is not the rate, it is the rate constant I am speaking about. So rate constant never depends upon the concentration of the reactant, but it depends upon two factors. One is the temperature and other is the catalyst. Okay. So we will also try to see unit of rate constant. Okay, how to find the unit of rate constant? We know that this is the rate law expression. Suppose rate is equal to K into A power N. Okay, there is only one reactant, and N we know it is the order of the reaction, correct? So, and how I can write the K? K is equal to rate divided by concentration of A raised to the power N. Now we know that rate, what is the unit of rate? We know that rate is equal to, we have learned, this is the instantaneous rate, dx by dt, where x represents what? Okay, dx, this x can be written in bracket. Okay, so x represents what? The concentration term, correct? And t represents the time. So concentration, I am using it as mole per liter. Molarity, I am using the term. So what I can do here? X is equal to mole per liter divided by time, dt, time. Then units of concentration. Here we know that A is coming. So that is a unit of concentration. Concentration is mole per liter raised to the power N. Correct? Now what you need to do? You can take this time on the numerator. So time raised to -1. So here mole per liter, here mole per liter raised to N. Now these two quantities are same. We know that A power M by a power n is equal to what? A power m minus n. We have learned this in maths. So what you need to do? Take mole per liter. This n is coming on the numerator. This is 1, correct? So this becomes 1 minus n. Then time raised to minus 1. Suppose there are cases where gaseous reactions happen. So in that case, the concentration, instead of concentration, we use the term pressure and like that. So what will come into picture? Atmosphere. The unit, instead of concentration, mole per liter, we use the term pressure. That means the rate law can also be expressed in terms of pressure. We will learn that. Okay. So in that case, mole per liter can be replaced by the quantity atmosphere, which is the unit of pressure. So atmosphere 1 power minus n time raised to minus 1. This is applicable for gaseous reaction. Please remember, this is applicable for gaseous reaction. Okay. So this is what about units of the rate constant. If you have any doubt, please let me know. Now next we will go to what I told as the mechanism of the reaction. Okay, so as explained, we are going in detail what is the order of the reaction. So as I told, order of the reaction, it is an experimental quantity. Please understand from where it is obtained. It is from the rate law expression. We have learned that. Okay, now what is order of the reaction? By definition, we can say it is a sum of the powers of the concentration of the reactants, where in the rate law expression, reactants in the rate law expression is known as the order of the reaction. So what is important to find out the order of the reaction? You need to get the rate law expression. So it is an experimental quantity, so that this expression they will give it in the question itself. You don't want to calculate it by any method. So if you see here, A plus BB giving product. So here small a and small b denotes the coefficient of A and B. Okay. Now if I am writing the rate law expression, rate is equal to rate constant into A power x and B power y. Then I can say x is what actually? X is the order with respect to reactant A, and y is the order with respect to reactant B. Okay, then what is the overall order of the reaction? X plus y. I am denoting that x plus y by the letter small m. So the small n denotes the overall order of the reaction. And please remember that this order is an experimental quantity, so that this order can be 0, or it can be positive value, or it can be negative value, or even it can be fractional value. For example, 3 by 4, 1 by 2, anything. Understood? So please remember that order can be 0, negative, positive, or fractional values. So I hope you understood what is order of the reaction. Next we will try to see what are the different ways in which a reaction can happen, mechanism of the reaction. Then we will go to molecularity. Okay. So next we are going to explain the mechanism of the reaction. So let us understand what is mechanism of the reaction. So mechanism of a reaction means how that reaction happens, whether that reaction is happening in a single step or it will take multiple steps or not. Okay, so based on that, mechanism of the reaction can be of different types. So first we will generally categorize this into two. One is the elementary reaction and the next one is the complex reaction. We will come to that. So what is elementary reaction? Elementary reaction means those reactions which completes in a single step. In one single step the reaction will get completed. Those type of reactions are called elementary reactions. Okay, and the properties of elementary reaction is, here if you see in an elementary reaction, if you write the rate law expression, its stoichiometric coefficient, I mean the exponential term raised to the concentration term. Okay, the exponents in the rate law will be equal to what? The stoichiometric coefficient of the reactants. Earlier I have told that sometimes this stoichiometric coefficient may be equal to what? This order. So in elementary reactions you can observe that here they have the exponents in the rate law will be equal to what? The stoichiometric coefficient of the reactants. Now let us consider an example. If A plus B giving you product, okay, is an elementary reaction. They have told it is an elementary reaction. Then I can easily say the coefficient of A and B, here it is 1, 1. And that 1 and 1 will be equal to what? The order of A and order of B, correct? So I can say rate is equal to K into concentration of A raised to the power 1 and raised to concentration of B raised to the power 1. Why I am writing like this? Because they told this A plus B is a what type of reaction? Elementary reaction. So as I told, if it is an elementary reaction, they have a property like their exponents in the rate law will be equal to what? The stoichiometric coefficient of the reactants. And please remember, this reaction should be a balanced chemical reaction. Okay. Now another important thing is, a zero order reaction can never be elementary reaction. Why? Because zero order means here the raised to the power term should be 0 actually. So 0 means whether it is possible, because if there is an equation is there, then surely there will be some coefficient will be there. Then if they say that it is an elementary reaction, then that coefficient can never become 0. So that's the reason why we say zero order reactions can never be elementary reaction. Zero order means here A should be raised to the power 0 and B also should be raised to the power 0. Then that quantity will become 1. Any term raised to the 0 will become equal to 1. So whether that is possible for any reaction, zero order reactions are there since order is an experimentally determined quantity. But if a reaction is an elementary reaction, its order can never be equal to what? 0. That is what is you need to remember. Zero order reactions can never be elementary reactions. And another important property is, for elementary reactions, fractional order is also not possible. So sometimes they say A raised to half and B raised to 3 by 4. In that case, I can say that whatever rate law they have given, it is not for and what reaction? Elementary reaction. Okay, so 2 points to be remembered. One is, elementary reactions cannot have a fractional order, and also zero order is not possible. Zero order value cannot be 0 for what type of reaction? Elementary reaction. Okay, I hope you understood. So we will see in detail the derivations for zero order, first order, then you will get a clear idea. Okay. Hi dear students. So next we are trying to learn the second type of mechanisms. So in the first we told mechanism of the reaction can be of two types. One was elementary reaction and the next one is the complex reaction. So from the term itself you could understand that complex means something not happening in a single step, correct? So I can say those reactions which happens in multiple steps, they are called complex reaction. Then a big question will come, then how we can find the rate of such a reaction? Okay, so please remember, if it is a complex reaction, the rate of that particular reaction depends upon the slowest step. Very important. We know that that complex reaction may happen in 3 steps, let it be 4 steps or whatever be it. So out of those 4 steps, which one is the slowest step? Slowest step that you can measure, right? You can measure the rate. So which one is the slowest step? We will write the rate law expression based on that particular slowest step. Why it is like that? Because if the rate of the reaction for the other steps is very fast, it is very difficult to measure. If it is a slowest step, it is very easy to measure. Understood? Because in the initial case itself, we have learned that those reactions which are moderate in nature, then only its rate can be measured. So that's the reason why we always prefer the slowest step whenever the reaction is a complex reaction. Let's go into it. So we say those reactions which complete in multiple steps are called complex reaction. For this reaction, we need a mechanism will be proposed. Okay, for example, suppose the reaction is 2NO2Cl giving you 2NO2, okay, plus Cl2. This is the reaction. And we know that this is not a elementary reaction and they say it is a complex reaction. So we need to propose a mechanism how this will happen. And they have experimentally found that the rate is equal to K into NO2Cl. Okay, so this is the experimentally determined expression. Please remember. Now we need to propose a mechanism so that we should also arrive at the same rate law expression. That is what I am trying to. So here from this I can understand that K into NO2Cl, its power is raised to 1. So I can say it is a first order reaction. Okay, now let's see. So mechanism says that we will take first one NO2Cl. Now this undergoes decomposition forming NO2 plus Cl. Okay, it is the slow step. Okay, from this the Cl, it's a free radical. Okay, Cl dot. This Cl dot immediately reacts with another molecule of NO2Cl forming, it is undergoing splittage forming NO2 plus Cl2. So if you add this, you can understand at the end of the day the final product is there is one NO2 here, there is another NO2 here, so totally 2 NO2. So and you can see here Cl2 is formed as the final product. This Cl has already reacted. So this is the mechanism. Now why this is the fastest step? We say chlorine, it is a free radical. Free radicals are very fast because they are with one single electron. They will all be always unstable. They will be trying to react with whatever existing species and form a stable compound. Understood? So we understood this is the slowest step. Now based on the slowest step, I will write the rate law. How? Rate is equal to rate constant into reactant NO2Cl, concentration of NO2Cl. So I can arrive at the same expression what we have determined experimentally. Understood? So this is how we used to write the mechanism for complex reaction. And please don't worry, sir, how we know how to write the mechanism. Don't worry about that. All the mechanisms and those things, you cannot propose anything. It is already found out already. It is already proposed. So in exams, they will give the mechanism and they will ask you to identify, write the rate law. Then what you need to do, you need to look whether which one is the slowest step among those. And based on the slowest step, you need to write what? The rate law. That is what. Understood? So it's very simple. Now we will see one more example to make you understand. Okay, now we will try to see the next example. So complex reaction, example 2. Okay, so the second example is regarding the reaction of NO with H2. So here two molecules of NO react with 2H2 gas, giving nitrogen gas N2, giving and water vapor 2H2O in the form of gas. Now experimentally the rate law was determined as rate is equal to K into NO square H2. Okay, so H2 the power is 1 actually. Okay, now we need to propose a mechanism. This is not an elementary reaction, this is a complex reaction. So we need to propose a mechanism. So the mechanism that has been proposed is, please listen. So the mechanism is 2NO. So 2NO in a reversible reaction, it will give you N2O2. That means 2NO any times will convert it to N2O2, and the backward reaction is also possible. That is N2O2 can get convert back to NO also. So this is a fast step. Now understand this N2O2 can react with the hydrogen, one molecule of hydrogen forming N2O with the H2O, and this is a slow step. Understand? So from this N2O further reacts with one more molecule of hydrogen because two molecules of hydrogen are available. So one more molecule of hydrogen to form N2 and H2O. And now if you see at the end product, two H2O are there. Here also one H2O, another H2O. So two H2O are there. And if you see final end product, one N2 was there. So here also one N2 was formed. And this intermediate N2O, it will react with the hydrogen to form this one. Correct? So now we know that from for complex reaction we used to write the rate law from the slowest step. So the rate law from the slowest step is equal to, rate is equal to this one, K into N2O2 multiplied by H2. So here comes the problem. Now when you are writing the rate law from the slowest step, you are getting this rate expression, but experimentally observed is K into NO square H2. Why this difference is there? The reason for that is whenever you write the rate law, it should not have any intermediate term. So here the problem here is this H2 means it is a term already there in the reaction. Understood? But N2O2, that is this term, this is an intermediate product. Correct? This is an intermediate product because NO is there, okay, correct. Then N2O2 is formed, then N2O2 reacts forming N2O. N2O is also an intermediate that is further reacting with the hydrogen forming this. So N2O2, it is an intermediate product. So we need to replace this N2O2 with the other terms. With other terms means how we can write N2O2 in terms of NO, that we will see. So please remember, whenever you write complex reaction, never write the rate law in terms of intermediate. First you can write it in intermediate terms, but later you need to convert that. Next step I will show you how to convert this N2O2 in terms of the initial reactant NO. Okay, here now we will try to see how to now replace N2O2. Now we know that in the first step 2NO is in equilibrium with N2O2. Now as per our chemical equilibrium chapter, we can write the rate equation for the forward reaction and reverse reaction. So R1, which is the rate of forward reaction, which is equal to Kf, that is the forward rate constant, Kf into NO the whole square. Correct? Please remember this, you have learned in chemical equilibrium first year. Now similarly for the backward reaction, how you write? R2 is equal to Kb into, at this point of time, this is the reactant, so N2O2, concentration of N2O2 raised to the power 1. So here raised to the power 2. How? It is based on law of mass action, correct? Now we know that at equilibrium what will happen? The rate of forward reaction will become equal to the rate of backward reaction. So R1 will become equal to what? R2. Then I can write Kf into NO square is equal to Kb into N2O2. Now what is the advantage of writing like this? If you write like this, from this the N2O2 can be written as how? Please listen. I am writing here N2O2, the concentration of N2O2 can be written as, okay, I am writing here for your understanding. So concentration of N2O2 is equal to, this Kb will come here, so I can write Kf by Kb, correct? Kf by Kb NO square. Correct? Kf by Kb NO square. So I can replace that in this equation. So let me rub. So now this is experimentally determined one. Okay. Okay. Now I am substituting this one. This is equation 2. This is equation 1. Okay. This is equation 1 and that is equation 2. So substitute equation 2 in equation 1. Okay. So if you are substituting, what will happen? Rate is equal to, what will happen? K into N2O2 will become Kf by Kb, correct? Into NO square, okay, then H2. Okay, so now again we can say all these values are constants. So this can be represented by a new constant, that is same rate constant only, but we will use a new letter, that is K dash NO square, okay, H2. Now if you see here, this rate equation and the experimentally observed rate equation are remaining the same actually. So that is the advantage. So please remember, whenever you are writing a multi-step reaction, suppose in the slowest step, if there is an intermediate comes, what you need to do? You convert this, or you represent this intermediate in terms of what? The starting reactant species, so that it will come like this, and you can substitute so that it will match with the experimentally observed rate expression. Okay, so I hope it is clear for you. If you have any doubt, come back to me. This is the pivotal point. This like questions usually come for exams. Okay, so next we are trying to understand the concept, what is molecularity. Okay, I can give you a simple idea. Molecularity means, very simple, the number of species that undergoes reaction. Or for example, if you have 3 molecules or 2 molecules are there, these 2 molecules will collide, correct, during the reaction and give you the product. Then my molecularity is 2. So that means, very simple, I can say the total number of molecules, or it can be atoms or ions, okay, participating in an elementary reaction. Why I am saying elementary reaction? That takes place in single step. In an elementary reaction is called molecularity of the reaction, because molecularity is always defined for single step, and single step reactions are called elementary reactions. It doesn't mean that for complex reactions there is no molecularity. There is molecularity is there, but for complex reactions, whenever multiple steps are there, there will be molecularity will be varying for each steps. Okay. Now listen here, these are the different properties. First thing, the molecularity is a theoretical quantity. It is something that we are defining based on the observation. So we say 3 species are undergoing collision to form a product, means my molecularity is 3. So we say first thing, it is a theoretical quantity. Then you can itself think molecularity, whether molecularity can be 0. 0 means what? There is no species reacting, correct? So molecularity will always be a positive integer, 1, 2, 3, like that. But it cannot be 0, negative or fractional value, because there is no meaning in that. Understood? So please remember, order and molecularity, the difference is order can be 0, negative, positive or fractional value because it is an experimentally determined quantity. Molecularity is a theoretical quantity and it can only have values like 1, 2, 3. Okay, and in elementary reaction the molecularity will be equal to the order. Why? Because in the case of elementary reaction we write the rate law directly from the stoichiometric coefficient. So if you have stoichiometric coefficient like 2A plus 1B, that means 2 molecules of A reacting with 1 molecule of B. So total how many species are reacting? 3. Then my molecularity is 3. So similarly order will be what? A square plus into B raised to the power 1. Then 2 plus 1 is equal to 3. Then order is becoming equal to what? Molecularity. Understood? So in an elementary reaction molecularity will be equal to its what? Order. Now the last one, in complex reaction the molecularity will be defined for each step. Normally this is not there in the syllabus, but you can see in complex reaction there are multiple steps, right? For each step we define the molecularity. And then some students used to say, sir, then what will be the molecularity of the whole reaction? So some books say that molecularity will be equal to the molecularity of the slowest step. Okay. And what is the maximum value of molecularity? As I told, it can be positive integers, but you cannot write it 5 or 6. Why? Because molecularity means the number of molecules that undergo simultaneous collision effectively. So at a time it is possible that 3 molecules can undergo simultaneous collision effectively. If you have more number of molecules, that simultaneous collisions will not be possible. So that's the reason why we say maximum value of molecularity is how much? 3. Understood? So very simple, the molecularity means the number of molecules or species that undergo simultaneous collision in a reaction, in an elementary reaction. Okay, it is a theoretical quantity. It can have values like 1, 2 or 3. It cannot have negative values, 0 or fractional values. And what else? You need to remember, for a complex reaction molecularity is defined for each step. And for elementary reaction the molecularity will be same as what? Order. Maybe I can explain that a little bit. So suppose you have an elementary reaction like, for example, okay, let's see, for example, you have an elementary reaction like this. This is for your understanding, okay? So otherwise some students will have a doubt. So you have an elementary reaction like 2A plus B is giving you C plus D. Okay, now we know that since it is an elementary reaction, my rate law will be what? Rate law will be rate constant into concentration of A raised to the power 2 and concentration of B raised to the power 1. Correct? So the overall order will be equal to what? Overall order will be 2 plus 1, which is equal to 3. Now if you see how many number of, for me molecularity is what? Molecularity is the number of species that undergo simultaneous collision. Here 2 A molecules and 1 B molecule is undergoing simultaneous collision. So 2 plus 1, 3. So I can say that molecularity and order is same for what type of reaction? Elementary reactions. Understood? Okay. Hi students, now let us try to do a problem based on what all we have learned up to now. Okay. See this question. The question given here is the following data is given for the reaction A plus B giving you product. Okay, what and all they have given? This is the experimental number 1, 2, 3. In the first experiment, they have taken the concentration of A as 1 unit and the concentration of B as 2 unit. Then what they have observed? The rate is 4 times. And in the second experiment they have doubled the concentration of A, it becomes 2, and they have maintained the concentration of B as 2 itself, then also the rate is 4 times. Now in the third experiment they have maintained the concentration of A as twice and B's concentration is doubled, then the rate becomes 16 times. Now they are asking you what is the rate law equation. So how to do questions of this type? Very simple. What you need to do is, first you need to say the rate is equal to K into A power X B power Y. Why I am taking A and B? Because they are the reactants. Why I am taking X and Y? Because I don't know what is the order. So I need to find out that. Understood? So let us assume rate is equal to K into A power X and B power Y. Now how to do it? Very simple. Now first what we need to do is, in this equation we will apply the data that is given here. So let us take the data 1 and 2. Why I am taking data 1 and 2? Here the concentration of B is fixed. So let me say first I am taking the data in which the concentration of B is fixed. So I know that rate at that point of time is 4, correct? 4 is equal to K into, what is A here at that point of time? 1 power X, and correct, what is B at that point of time? 2, so 2 power Y. Now similarly take the second experimental data. So here B is fixed, so A is the rate is again 4, correct? Then K into, tell me what is A? A at that point of time is 2, so I write 2 power X, and what is B at that point of time? It is 2, so 2 power Y. Now if I have similar quantities, the advantage here is I can divide here. I am dividing this equation with this. So this is my first equation and this is my second equation. I am dividing equation 1 by 2. So what will happen? The value will become 1 by 1 on the LHS, because 4 by 4 is 1. There the K and K gets cancelled off, and 2 power Y will get cancelled off, and this will become 1 power X and 2 power X, correct? Now we know that both are similar quantities, so I can write it as 1 is equal to 1 by 2 the whole power X. Now tell me what can be the X value so that this becomes equal. So I can say here what can be the value. So this 1 by 2, this becomes, should be equal to 1. So I know that if I put X is equal to 0, if I am putting X is equal to 0, what will happen? This will become equal. 1 is equal to 1 by 2 the whole power 0, that is 1 equal to 1. Understood? So I understood that X value is what actually? 0. So X is equal to 0. I have identified. Now I know the order with respect to A is 0. Understood? Now similarly I will try to identify the Y value. Okay. For that, what I am doing here is, please listen. Okay. So here one change I am going to make. Now I need to fix the value of A to identify B value. So I know that in experiment 2 and 3 A value is fixed. So let me apply experiment 2 and 3 over here. So rate at that point of time is 4. If I am applying experiment 2, rate is equal to 4. K into, what is A at that point of time? A is 2. So I write 2 power X. And what is B value at that point of time? B is also 2. So B is also 2. So 2 power Y. Now apply the experiment number 3 to the same equation. So rate is 16. K into, what is the rate? A value, that is 2. So 2 power X. And what is the B value? That is 4 power Y. Now I will mark this equation as 3 and this as 4. Okay, now you might have understood. We have common term with X. So let me divide 3 by 4. So on dividing 3 by 4, what you will get? 4 divided by 16 is equal to, this will get cancels off, then 2 power Y divided by 4 power Y. So how I can write? This will become 1 by 4. This is equal to 2 by 4 whole power Y. Correct? So this can be written as 1 by 4 is equal to, this will become 1 by 2 the whole power Y. Now how I can equate this? I can make this 1 by 4 as 1 by 2 the whole square. 1 by 2 the whole square is equal to 1 by 2 the whole power Y. So if I compare this, I will understand Y is equal to 2. Correct? Now I got Y is equal to 2 also. So now tell me what is my final rate law expression. So how I can write? So I hope this is clear for you, right? So let me rub this. Now I can say the final rate law expression is what? Rate is equal to rate constant a power 0 and b power 2. Understood? So this is how you determine the rate law expression when questions like this comes. Okay, thank you. Okay, let's start doing the next question. Please go through the question. For a reaction 3A giving you products, it is found that the rate of the reaction doubles if the concentration of A is increased 4 times. Calculate the order of the reaction. This is what they are asking you. So let us try to write the rate law expression with the assumption. So rate is equal to rate constant times you have the reactant A power X. Okay, since they are not speaking anything saying that it is an elementary reaction or nothing, we assume it's a complex reaction. Nothing is told. So we say rate is equal to K into A power X. X we don't know. That is what we need to find out. Now they have given you some clues. They told the rate of the reaction is doubling. So we say rate becomes 2 times the rate when the concentration of A is increased 4 times, that is A becomes 4A. Correct? This is what they have given. Now let us assume we have 2 equations now. So this is equation 1 and this is equation 2. So let us divide these 2 equations. Equation 1 by 2. So what will happen? This will become 1 by 2 and this is equal to this 2 will get cancels off. And you have A power X divided by 4A whole power X. Correct? So we can write again this as 1 by 2 is equal to, we can write it in single bracket. So this will become A will get cancels off 1 by 4 the whole power X. Correct? Now we know that A power M raised to n, this can be written as A power mn, we have learned in maths. Now similarly we can write here 1 by 2 is equal to 1 by 2 the whole square raised to x. Correct? So what this will become? I can write 1 by 2 is equal to 1 by 2 whole power 2x. Now we can compare this, both are 1 by 2, this is raised to 1. So I can say 2x is equal to 1. So you have 2x is equal to 1, or I can say x is equal to 1 by 2. So x is equal to 1 by 2 means my rate law will become what? Rate is equal to K times A power 1 by 2. So what is the order of the reaction? So from this I understood x is the order. So order of the reaction is half. So that means it is a fractional order reaction. Understood how to do this? So please, if you have any doubt, feel free to come back. Thank you.